Okay, this is the last video we've got going on today. This time we are going to look at size. So size could be size of the stuff itself if you are dealing with a solid. It could be size of the container if you're dealing with a liquid or a gas. Okay, for our first example, we're going to look at water. So we're going to assume in this case we are dealing with liquid water. Okay, so thinking back to our last video, solids, liquids, and gases, we're dealing with that middle box where the particles, or in this case we're talking about water, so the water molecules are slightly spread out, but they are not completely spread out so that they are in gas form. Okay. When we're talking about water, we could actually draw the water molecules, right, with the oxygen and two hydrogens attached, or we could continue just drawing them as circles in our particle diagrams. To make things easier, I'm going to continue to draw them as circles. If you want to draw them as water molecules, you're welcome to do so. Okay. So what we know about size and its effects on density. As long as we are dealing with the same substance in the same state, size doesn't really make a difference, okay? So if we think about water, let's say that this is our water sample. Okay, if I look at that sample, there are 9 particles in that sample, just because that's how I've drawn them. If I then take that sample and I move it over here, imagine taking this smaller cup of water, pouring it into a bigger cup of water, right? If I don't add any more water, I'm still going to have those same 9 particles spread out the same amount, okay? So technically, there would be no change in density here. But if I fill this water cup all the way up, now I've added more water. So is that going to change the density? So let's say here I'm going to add more water. Well, now I've got more particles in here. So if I've got more particles, that should mean it's more dense, right? That was what we learned on that first one about different materials. Here's the catch. These are both water. So remember when we started, we said substances, density is one of their properties, right? So all water that is liquid water has the same density. So it doesn't matter if I have less of that or if I have more of that. Okay, this will make a little bit more sense when you get into calculating things with Mr. Schmidt next week, right? Because you're going to increase both the mass, the amount of stuff that you have, and the volume, the amount of space that stuff takes up. Okay, so less mass, less volume. More mass, more volume. So when you put numbers with this, it helps you see it a little bit more clearly. For now, what you need to know is that because density is a property of a material, as long as the material stays the same, the density is going to stay the same no matter what size sample you have. Okay, so I want you to practice one. Here are 2 samples of copper. You have a smaller sample and a bigger sample. Pause the video and draw 2 samples of copper that have the same density. Okay, think about what that would look like. Remember that copper is a solid. We just drew water, it was a liquid. So your particles should look a little bit different in this sample. Okay, but they should still end up having the same density. So go ahead and pause the video right now. Come back when you're ready to check your answer. Okay, so looking at this, when you've got copper, you've got 2 samples of copper. Remember, size shouldn't matter. So if you double the size, you're going to double the amount of stuff that goes into it. So smaller sample, solid, particles close together. bigger sample, particles still have the same spacing, we can just fit more of them. Same size particles, same spacing between the particles, bigger sample just means more particles, which in this case are copper atoms. Both samples would have the same density.